Welcome back to another Minicast hosted by the NC2 Conspiracy Channel. My name is Simon.
I'm Chance.
Before we get started today, I would just like to thank all of our listeners. They support us emotionally, and I'd like to thank our patrons for supporting us financially, which is why you're able to hear us today. So if you want to support us financially, go visit us on Patreon, NC2 Conspiracy Podcast. Chance, what are we talking about today?
Science.
All right.
Today's going to be a fun one, I think. I like
I'm ready.
Space and everything like
This
that.
beer's good.
Yeah. Well, should we say what we're drinking?
We might as well. It's a special one. We're drinking an Ace Perry Craft Cider. Is this pear flavored?
Oh, I
It
guess
tastes
maybe.
exactly like a green apple Jolly Rancher, if you hadn't noticed.
I hadn't. Thank you for ruining it for me.
Made in California, 5% alcohol by volume. Enough said. Anyhow,
Enough said. So we're talking a little bit about a couple different things today. I think it's going to first start off with how do they, and by they I mean the peeps,
them.
How do they know that we can observe the material that objects are in space, with this accuracy that they?
How do we formulate what celestial bodies are made out of that we cannot physically reach?
Yes, in a better way. Yes, that is the statement.
I'm just making sure I'm following.
No worries. So I did some research on it and stuff, and there's a couple different ways, but the main one is a spectrometer.
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 The spectrometer.
Yes, that
Okay.
too. So basically what for
Jesus.
Jeez.
Dude.
Might have to cut that one.
The people are going to... Yeah.
I don't know what happened. You got me sick.
You're
That's what
dying.
happened.
Yeah, I know. He's dying.
Give me 1 second. Gotta get a good cough in.
Play some... I don't know.
Or just cut it out.
Go for it.
All right. So for what people don't know, a spectrometer basically is a machine that processes light and at its fullest, like through a prism. So the prism will break down the light into its different colors.
The full
and
spectrum.
Yeah, the full spectrum or spectra. And then from there you can analyze what material supposedly, because every material gives off a specific type of light when it's processed through this machine. You can know what material that is made out of, such as iron produces a specific type of color
By measuring the amount of each wavelength that is received by the spectrograph.
Yep, along with
Spectrometer?
there's
Spectrometer?
the other version of it is a very similar process, but it uses hydrogen. And then based on the process of light through the hydrogen will have on the machine basically a line of, based on I think what its actual material is, the hydrogen will process it differently or fall in a different line of the light.
Gotcha.
That one was much more sciencey.
We're not scientists. Full disclosure. Neither of us are scientists.
I am widely refused by all scientists.
He is refused by science, and I am also refused by science.
Yeah.
And if you're listening, you're probably also refused by science.
But so that was the main one. And I did some research in the spectrometer and the telescopes we have. And one thing I learned about it is that they can process light. And at the end of the day, it's like a best guess situation.
This is true.
So when we're processing light that travels from that distance, there can be things that affect the light and things like that. There can be interferences here on Earth through some of the other equipment they use to measure this. So basically what they're doing is they're using several types of techniques, and then whichever ones come out through the presses per se, and they're oh yeah, it shows iron on this one. Well, does it show iron on that one? Yeah, it shows iron on that one. Okay, does it show iron? And they process it that way so that they have more accuracy.
Sure.
But by far, this does not seem like an accurate thing to do.
Sure. And for those who maybe aren't following completely, we are talking about using sciences to determine the material makeup of celestial bodies that are light years away. Places we could not currently physically reach, but we have determined the exact chemical makeup of these celestial bodies. And we wanted to discuss that a little bit because people often view it as fact. And that is because it is printed in textbooks.
Yep.
You can crack open a textbook and it will state as fact the chemical composition, material composition of various celestial bodies that we have never even dreamed of reaching.
Yeah. That's my main,
that's my
qualm with it all.
Right. And that's common practice. It's stated as fact, and that is because it is our best guess as society.
And I'm okay with a best guess situation.
It's when you present it as a fact.
Yes.
That's when it's odd. But that's kind of what we're talking about.
I don't like hypotheses and stuff anyways, where you through this proven method that I use, this is fact until proven or until disproven.
Right. It's theories. Just a few things off the top of my head that could affect something like that using the spectrometer or spectrometer. I'm gonna call it a spectrometer because I like spectrometer. Actually, before that, fun fact: the first spectroscope was invented in 1859 by German chemist Robert Wilhelm Bunsen and the German physicist Gustav Robert Kirchhoff. Just fun fact, since I happen to have that handy. But anyhow, it is stated that there are many things that can affect the results of these tests. If you look it up on any website, it will tell you that there's a lot of things that can affect it, and that's because light is actually affected by many things, including gravity, and also including the celestial body that we are reading from moving.
Yep.
Can affect it. That can affect the wavelengths that are sent out, as well as the wavelengths that are received or not received, or if there happens to be something in the way that absorbs some wavelengths.
Dust clouds and things.
Dust clouds, which there are many of.
And then we're not even mentioning the fact that there's material that we know of in the universe that doesn't reflect light.
This is
doesn't
true.
reflect. I don't know if it absorbs, but at the same, basically, it doesn't exist in the material plane as we can see it.
Right.
Because it doesn't reflect the light. Because if you can see a piece of wood on the ground, it's because that wood's reflecting light, and therefore you can process that information as a material object in front of you.
Yeah. We are still actually learning things about the material composition of our own planet on an annual basis.
Yeah.
To the point where we are rewriting textbooks on the regular with new considered truthful information.
Yep.
And that's not because it's lies and they're feeding you lies. It's because as we grow, our knowledge
grows.
As we grow, our knowledge grows. Exactly. And the same thing happens with these celestial bodies that are way out there. This always puzzled me. As a child and still. And so I'm glad we're talking about it, because you would watch something on the Discovery Channel or whatever about something that's so far away, and they're like, it is blah, blah, blah million light years away and composed out of 80% this, 10% this, 5% this, and they'd list everything that it's made out of. And I always thought that was so bizarre that we can learn things about our own air on an annual basis, but we somehow are sure to the percentage, sure enough that we write it down in a book and teach it to children about what something thousands of light years away is made out of.
Yeah.
It's interesting because, like we were saying, there's a lot of things that can affect that, even fairly locally. But when you go to the extent of viewing celestial bodies or gas clouds, they do have gas clouds and stuff like that too.
Yeah.
You're talking the distance that light travels in thousands and thousands of years. It is that far away. Mm-hmm. And we are thousands of light years. That's what that is. Thousands of light years away. And we are determining and teaching as if it is a sure thing what these are made out of.
Well,
and like you said, there's some things that don't emit light, and there are some things that do not reflect light, and there are some things that we still just don't understand.
Yeah. I mean, let's put it this way. A paper was released that we quite possibly have an evil twin to our sun.
Yes.
That is invisible to the naked eye.
Right.
Because it emits an ultraviolet or ultraviolet light that we can't visibly see, and its orbit by math and just calculations and stuff.
They've decided that it could potentially be the sister.
Yeah, I think it's supposed to like orbit and swing by close enough to disrupt our solar system, like what, every 7 million years or something like that. But
It has a way cooler name too. It's called HD 162826.
yeah,
I wish that's what our sun was
and
called.
we can't visually inspect this twin sun of ours.
No, we just
they're
learned.
almost sure exists. They're almost sure it exists,
Right.
but you can't measure any of the material or anything.
So we just figured out something new about our own solar system, yet we make such leaps and grasps as to determine the chemical makeup of something that's so far away, we don't even know how we would ever be able to get there.
Yeah.
We can only see it, and we are only seeing a past version of it on top of that, to be honest. Because if something is 1,000 light years away, then the light we are receiving from it right now is the light that it emitted 1,000 years ago.
Yeah.
So we are determining the makeup of it 1,000 years prior to today, and then teaching it in the books like that is still what's going on. And I just find that to be very interesting. So it's a good topic to talk about.
Yeah, and that's the gist of it, is the fact that there's this kind of unspoken conspiracy of like presenting this as hard facts. And I get it, best guess until proven wrong kind of thing. We got to go with what we can ultimately, justify as information just to get other people motivated. But at least, be honest about it.
Right.
I guess. I don't know. It's that plus the age thing, like how they tell how old things are. We've discussed this a little bit before.
We have discussed it. And
mainly about the carbon dating, but
we talk about carbon dating, and I don't want to talk about that too much this time because I still want to do a whole episode on that. But on that note, to bring it back a little bit more local, it is considered that our universe is right about 14 billion years old.
that's about as local as you can get.
And that is taught, well, that is a hard number that is taught in books today.
Yep.
Is that our universe is, I think it's actually 13.8, roughly 14 billion years old. And our own Earth is 4.54 billion years old. Do you know how we determine how old the Earth is and how old our solar system itself is?
I'm assuming we cracked open a rock.
Basically. So our entire solar system we've determined is 4.571 billion years old, and Earth itself is 4.543 billion years old. The Milky Way being 13.5 billion years old. The universe in a whole being 13.8 billion years old. We have determined how old our solar system is because that's the oldest thing we've found so far. That is actually how we've done that.
Yeah.
Using carbon dating, and I forget which actual element it is that we check the half-life of, because that's essentially how you determine how old something is checking the radioactive decay of it. The oldest thing we have found so far that we have decided came from Earth is 4.543 billion years old due to carbon dating. That is why we say our Earth is that old. And as far as why our solar system is 4.571 billion years old is because that is the oldest meteorite that we have found.
Yep.
And so that's
the oldest one
that we
found.
determined came from our solar system. So we determined it came from our solar system.
Somehow.
Well, for one, it is considered common knowledge that the solar system, our solar system, formed at the same time. It all formed at the same time. And so if you check the actual age of most of the celestial bodies in our solar system,
They're about the same age.
They're going to be the same. Solar system
Give or
is
take a couple
4.5, Earth is 4.5, Moon is 4.5, Mars is 4.6, Saturn is 4.5, and this all comes from carbon dating
Why
things.
is Mars slightly older?
Doesn't matter. They found
I'm just
a rock.
saying.
They found Saturn and Jupiter the exact same ages. Mars being 0.1 billion years older, exactly. Neptune is the same age as Jupiter. Mercury is the same age as Neptune.
But all right, so for everyone out there, the reason this relates is because it's not just carbon dating. Like we were saying, we also measure the material they're made out of, like these celestial bodies of significance at distance through light. But we glean, or we supposedly glean, their age based on their system, like such as the star that's their host, what stage it's in, whether it's a white dwarf, brown dwarf, like blue giant. Those things, like that's how they supposedly gain the age, and it's all through light. Which for me is like the most manipulable thing in the world.
To be manipulated by gravity.
Everything can manipulate. I could put a wall up and manipulate.
Now, how we find black holes is we look for warps in light.
Yeah.
Because a black hole, due to its immense pull, will actually bend light around it. And that is how we are able to locate black holes, is you look for celestial bodies far off that will disappear from line of sight for a second and then come back, because that means it moved behind something that is either absorbing or redirecting the light. And so the light can be bent easily.
I mean, that's what a prism does. Is it bends the light and breaks it down into its base colors. And
yes, right.
So,
and like the age of our sun, well, is partially determined the same way. We have found rocks, and we have determined that since the entire solar system came at the same time, that the oldest thing we can find in our solar system is the age of the sun. That is how we have determined that.
Wait, is it over 4.6 billion years
No,
old?
it is 4.603. That is the oldest number you will find within our solar system.
It's just barely older than Mars.
No, it's the same age as Mars. And actually it is the exact same age as Mars, 4.603 billion years, which makes it 0.1 billion years older than Jupiter, Saturn, Mercury.
These are like guesswork numbers at best, man. There's no way.
It really is. And there's nothing wrong with that, because we need to have these numbers to go off of.
Yeah, we have to have a starting point.
Exactly. And
But
that
if you
is
have
the
wrong
starting point. That's what I'm saying, is that you can have the wrong starting point. Starting from there, come up with completely false numbers. And we still teach it because that is, to our best knowledge, what is to be true.
Yeah.
But that doesn't make it true.
That doesn't make it true, and people shouldn't act like it is.
Look into it. Go, if you have like old textbooks lying around from the same classes, go compare some of the numbers in them, because they will be different. We rewrite textbooks. That's why schools restock textbooks. Yeah. Believe me, if they could use the same crappy ones that people have been drawing in, they would. They replace them because new information comes out, and eventually it actually becomes mandatory that you need to get new ones, because they made a big enough discovery that they're like, oh, you can't teach that. That's too false. We need to start teaching this instead.
Yeah.
So I find that really interesting. I also did not know that Venus or whatever, no, Mars and
Mars and the sun
Mars
are
and the sun
supposedly
are the
oldest
same
things in our solar system.
Right. And that tells me that all of these ones that have the exact same age on them, that means we are assuming they are the exact same age as the sun. And I'm not going to get way into it, but if you were to go and look up a video on how our solar system is formed, you would learn why.
That is incorrect, like beyond belief.
It could, but you can learn why they think that our universe was all put together at the same time. And it's funny because as we are able to study more and more our surroundings, we have like private companies now that are in outer space. Shout out SpaceX. People are doing like their own journeys and stuff. We're constantly finding things where we're like, wow, that doesn't make sense at all.
Yeah.
Like when we did a whole episode on the artificial moon. Calling it artificial was kind of a view grab, but at the same time we talked about it a lot.
But it's not wrong.
It's not exactly. It's not necessarily wrong, but we talked about a bunch of facts in that are basically just proving that our moon it's not possible that it came to be the way that we're taught that it came to be.
Yeah.
And people are starting to realize that.
Yeah.
Why do you think there's a sudden race to the moon happening again after everyone stated that it wasn't important at all?
Literally, NASA said we have nothing else to learn from the moon. And then 20 years later or whatever,
everybody's racing to the moon and Mars again.
Crap, we need to get to the moon.
Exactly. We need to get to the moon because everyone else is getting to the moon now. So yeah, I just think,
I mean, that's what it comes down to. That's the big conspiracy, is that science is only the best guess out there.
And I'm not telling people to ignore science.
Oh, no.
Read the books, understand the guesswork, understand why and what they used to come up with these numbers, and then maybe do your own research and come up with your own opinions on things that you're interested in.
And then maybe motivate yourself to prove them wrong.
Motivate yourself. Okay?
Motivate yourself to prove them wrong. Be like, there's no way Mars is 4.603 million years old.
Happens to be the same age as the sun. Exactly.
But all the other planets waited around a couple billion years to like
Before they formed.
before
they
half a billion
showed
years,
up.
whatever.
Yeah. Yeah, because that's how something like the big debate over the moon comes up. And it's being considered less and less conspiracy and more so alternative science. Because people are looking into their own things, and some of these people are very educated people.
Yeah.
It's not just a bunch of
Us.
It's not just it's not just a bunch of us, but these are educated people that are coming up with numbers and facts about our moon that disprove the fact that it came to be the way we think it did, and the fact that it is the exact same age as the Earth.
My favorite is that it was we were a binary planet system, and then with the Roche limit, we tore apart down into this smaller stub that moved away far enough to not be torn apart anymore. We absorbed the material and then became...
See, I've heard of that. And
That's my
we
favorite
talked
theory.
about that.
That's my favorite theory.
Yeah, and we talked about that, and people are starting to realize that maybe something like that actually makes more sense than what we thought, due to the perfectly circular orbit and stuff like that.
Yeah.
And so now I'm going to go like way out on a limb here, and I'm going to make a bet that over the next 5 to 10 years, with all of these people planning to make missions to Mars, some of which are private companies that maybe can say whatever they want, maybe say what they figure out when they get there, we'll probably learn that maybe Mars isn't the exact same age as the sun. It might not be.
That kicks my butt.
I know. I didn't even realize until I was...
Well, when you were saying the numbers, I was just like doing math in my head, and I was like, wait a minute. Why is Mars older than everybody else?
Yeah.
And the same age as the sun?
No, I mean, that's funny, though. And that's why a lot of times...
Technically, or just on a science level, technically Jupiter should be the oldest one, because it's a gas giant, which means that the sun and Jupiter were fighting to become a star around about the same time. They had collected up the same amount of materials and gases. Jupiter didn't collect up enough to actually go through the nuclear reaction to turn into a star. Our sun did. So technically Jupiter should be the one that's like the closest to the age of the sun, probably, in my opinion.
Well, it's actually the exact same age as Saturn and Venus and Uranus.
Yeah.
And Neptune.
What is going on?
Yeah, so...
That bugs me. Like, that actually, like, that'll probably keep me awake at night a couple nights.
Yeah. It's worth thinking about. And, yeah.
We know less about our own solar system than most of the rest of the
universe. We know
universe.
less about our own solar system than we claim to know about things that are so far away, we don't even know if they exist anymore.
Yeah, that's
literally...
That's the best way to phrase that. We don't even know they exist anymore.
And it's important. It's important to reach out and make that guesswork about things that are far away. It's important for exploration. It is. Mm-hmm. But maybe we should learn more about what's going on right here. And we are doing that as all of these companies are showing up, and technology has allowed private companies to...
Or maybe just give Jimmy a break on the test when you ask how old Mars is, and he's off by 0.3.
And he's off by 0.3 because everything that's in the book is guesswork anyhow.
At the best.
And so it's like, that's accurate guesswork, as accurate as we can get. But we could find out one thing that totally throws all the numbers.
Oh, yeah.
It happens all the time.
I think it'll be dark matter.
Think of how often someone comes up and they're like, actually, it's this way. And people go, oh, crap. We've been teaching the wrong thing this whole time. The Earth was once flat. Maybe it still is.
Yeah.
We won't get into that. This is supposed to be a mini episode, so I don't want to push more than like 25, 30 minutes.
Yeah, and I think I just have one little extra thing to add.
Let's hear it. I'm ready.
About the dark matter thing. So, this isn't really related to it as much, But there was something I learned a while back ago through like one of the papers I was reading and watching some videos on. And it was interesting because it made sense in my head when I processed it, but I don't know for sure I'm reciting it 100%. But they were talking about dark matter or dark energy, how all matter, seeable matter, like visual matter, has like gravity, basically, is the best way to put it.
Right.
And it attracts. But this paper talks about maybe, just maybe, gravity does attract, but maybe it has assistance from dark energy or dark matter that actually is a antimatter that actually repels matter. So like it's kind of a positive negative thing. And that made a lot of sense in my head because everything has an opposite and, equal reaction kind of thing. Like, you get where I'm going with this.
Yeah.
Magnets kind of thing. So like lots of different things. So it made a lot of sense to me, and I thought that was interesting. And I wonder how it would affect light in its own way.
It could throw the numbers so hard that everything we've been taught so far could just be complete bogus.
Yeah.
And that's okay. I would like to live to see that happen. Not to prove science wrong or something like that, but that would just be such a huge leap. We'd have new numbers to go off of, and you can learn new things.
And we'd learn that the universe was actually 27 billion years old, not 14.
Not 14. Well, yeah, right. Yeah, I know. Yeah, I'm not going to get into a rant about that. The universe is determined how old it is because of how fast it's expanding, but we don't know its origin point. That's all I'm going to say. That's all I'm going to say.
That's exactly
how
what
do you
we
know
were
how
talking
fast
about.
it's expanding if you don't know the origin point? That's all I'm going to say.
Exactly.
I'm not going to say anything else. That's it.
I'm 100% on board with you. If you don't know the origin point, how can you measure its
Well, we found a
actual
really
speed?
old rock
No.
that we determined didn't come from our solar system. It's not our solar system that's 14 billion years old. It's the universe. Anyhow, we'll call it quits there. Try not to make this one too ranty. We're not scientists. We are not saying that science is wrong, but we are saying that it is by nature not fact, but our best guess, which is important. Mm-hmm. Scientists keep doing what you're doing, and we're going to keep doing what we do so that people don't blindly follow textbooks. But thank you for listening. Again, thank you to our patrons. They support us monetarily so that we can sit around and talk about this sort of thing, which is funny. Yeah. If you want to join our patron list and support us sitting around talking about this sort of thing, you can find us on Patreon, NC2 Conspiracy Podcast. You can donate as little as $1, and you get access to post-podcast podcasts that we post after every full-length episode, and it's just additional content where we banter and speak about podcast analytics and numbers and sometimes giant squids and movies. Exactly.
Yeah.
And we really just have a good time. If you're trying to recommend us to somebody or want to know where all you can find us, the easiest way is just to Google. If you Google NC2 Conspiracy Podcast on Google, there's like 2 pages of where you and your friends and loved ones can listen to us.
And the occasional stranger.
Those include iTunes, Spotify, Google Podcasts, iHeartRadio, Stitcher, maybe Pandora. They didn't get back to me yet. I don't think.
We'll have to double check that one after this.
Pandora's in the works. YouTube. We post to Podbean. It goes directly to Facebook. A link goes to Twitter. You can find us on the Himalaya Podcast app. Castbox for our Android users, Pocket Casts for our Android users. We're all over, so give us a follow, give us a like, give us a comment. It all helps and goes to a great cause.
And we like hearing from you guys.
We do, even if it's you telling me that the background music sucks. I still enjoy reading that every night before I go to sleep.
I know. We had a long discussion about it, and we were like, ultimately, it's staying.
Ultimately, it's staying, at least through the end of the season.
At least to the end of the season. Maybe next season. Can't switch it up now.
Maybe next season, dude. We got a format going. All right. Thanks for listening, everybody, and we'll catch you in the next episode of the NC2 Conspiracy Podcast.
Goodbye.